Today we will be talking about choosing a catcher. In the 2009 Major League Baseball playoffs, manager Joe Girardi of the New York Yankees made headlines by choosing weaker-hitting backup catcher Jose Molina to start games pitched by A.J. Burnett, instead of regular catcher Jorge Posada. The manager's reasoning was that Burnett seemed to pitch better with Molina catching rather than Posada. Is this true? There are many ways to measure a baseball pitcher's performance. One of these is the opponent's batting average, which is the batting average of all hitters when facing a certain pitcher. During the 2009 season, opponents were batting .270 against pitcher A.J. Burnett when Jorge Posada was catching, but batting only .221 when Jose Molina was catching. Here is a two-way table summarizing these performances. Create a graphical display to compare A.J. Burnett's performances with Molina as a catcher and with Posada as the catcher, and briefly describe what you see. So you'll see the display is already created. With Posada, the batting average was .270. With Molina, it was .221. So you would say that opponents' batting averages were higher with Posada as a catcher than Molina. State the hypotheses we're interested in catching. So our HO would be Burnett has the same ability when Molina is the catcher and when Posada is the catcher. Our HA would be Burnett has a greater ability when Molina is the catcher than when Posada is the catcher. What is the test statistic we will use to test these hypotheses? And what is the observed value of our test statistic? So our test statistic is going to be our batting average for Molina minus the batting average, the batting average for Posada minus the batting average for Molina. And the reason why it's in this order instead of Molina minus Posada is because it's better to have a lower batting average. If you did Molina minus Posada, you would have a negative value, and it's just easier to read if you're looking for positive numbers. So that would be 0.270 minus 0.221, which is 0.049. Describe how to use note cards to simulate the distribution. So we would need 635 note cards. Aren't you glad you don't have to make them? And we're going to write hit on 159. And out on 476. Then we're going to shuffle them. And divide them into two piles. And that will be 253 for Molina and 382 for Posada. Then we'll calculate the batting average for each pile. Or we could say the proportion of hits. Either one is fine. Subtract. Make sure you go in the same order, so subtract Posada minus Molina. Plot it on a dot plot and repeat many times. So we did 100 trials in a simulation and came up with the dot plot below. And it says, what information does the dot plot provide? So we would say the dot plot shows the possible differences in opponent's batting average that could occur by random chance, assuming Burnett has the same ability with both catchers. Estimate and interpret the p-value. So our value was 0.049. So you need to make sure that you're reading the right numbers. So 0.049 would be just before 0.05. So we're looking at all of those. So our p-value would be 11 out of 100, or 11%. Based on the p-value, what would be an appropriate conclusion? Well, remember our numbers from the last lesson. 11% is higher than 5%, so we would fail to reject. We would say we do not have convincing evidence that Burnett has a greater ability with Molina as catcher than Posada. If someone decided that Burnett's ability is greater with Molina catching than with Posada catching, can we conclude that the difference was caused by Molina? And remember that I told you before, unless it's an experiment, you can never say the exact cause. So we would say no. There could be other factors. Such as improvement or injury. And again, whatever you put here is fine as long as it's not too far off the wall.